For decades, our world has been built on a foundation of logic, a digital landscape of ones and zeros. Classical computers, the engines of our modern civilization, have solved immense challenges, connected billions, and created empires of information. They are marvels of human ingenuity, machines that follow our rules with unwavering precision. But what if the next great leap in computation isn't about following rules, but transcending them? What if the next generation of machines could think beyond the rigid confines of logic and step into the strange, probabilistic world of the quantum realm? A realm where the very laws of reality seem to bend, and the possibilities are not just vast, but truly infinite. We stand at the precipice of a new dawn, one that could redefine what it means to calculate, to create, and even to exist. This is the story of the machines that will change humanity forever. To understand the quantum revolution, we must first abandon our everyday intuition. Imagine a light switch. A classical computer bit is like that switch can be either on, representing a 1, or off, representing a 0. It's a binary choice, simple and clear. Now, imagine a dimmer switch, capable of being at any point between on and off. Quantabit, or a qubit, is something far more profound. Thanks to a principle called superposition, a qubit can be both 0 and 1 at the same time, existing in a cloud of probabilities until it is measured. Okay? Think of it this way. A classical computer is like reading one book at a time, page by page. A quantum computer, by leveraging superposition, can read every book in the library simultaneously. But the true magic lies in another quantum phenomenon, entanglement. When two qubits are entangled, they become linked in a way that defies classical physics. Measuring the state of one instantly influences the other, no matter how far apart they are. Einstein famously called this spooky action at a distance. It's through these two principal superpositions, the entanglement, that quantum computers shattered the limits of classical computing, promising a computational power so vast it's difficult to even comprehend. Right now, in sterile, clean rooms and top-secret laboratories across the globe, a silent race is underway. The world's superpowers and tech giants, names like Google, IBM, and emerging innovators are locked in a new kind of arms race. The prize isn't territory or weapons of mass destruction, but something far more fundamental: the control of computation itself. Billions are being invested, and the brightest minds of a generation are working tirelessly to build a stable, scalable quantum machine. Headlines flash with claims of quantum supremacy, a milestone where a quantum device performs a calculation that no classical computer could ever complete in a reasonable time frame. We see glimpses of these prototypes, intricate chandeliers of gold and superconducting wire, cooled to temperatures colder than deep space, all to protect the fragile quantum states of just a few dozen qubits. The competition is fierce. The stakes are monumental, because the nation or company that first harnesses the full power of quantum computing won't just lead the next technological era, they will hold the keys to the future. With unimaginable power comes unimaginable risk. The very foundation of our digital world is built on encryption complex mathematical problems that are possible for even the most powerful supercomputers to solve. Our bank accounts, our government secrets, our private messages, all are protected by these digital locks. A mature quantum computer could, in theory, pick those locks as if they were never there. With this power, every secret code could be broken, every digital wall could crumble. In a post-quantum world, the concept of digital privacy could become a relic of the past. The potential for chaos is immense. Financial markets could collapse overnight. National security systems could be rendered obsolete, and the trust that underpins our interconnected society could be shattered. We are forging a tool that could either be used to build a better future or to dismantle the one we have built. The question is no longer if this power will arrive, but who will wield it and for what purpose. Yet, for every shadow of peril, there is a beacon of hope. If we can steer this technology with wisdom and foresight, its potential to benefit humanity is boundless. Imagine designing new drugs and therapies not through trial and error, but by simulating molecules with perfect accuracy, leading to cures for diseases like Alzheimer's or cancer. Picture creating revolutionary new materials capable of conducting electricity with zero resistance, or pulling carbon directly from the atmosphere. It's helping us solve the climate crisis. Quantum computers could unlock the next stage of artificial intelligence, allowing machines to learn and solve problems at a speed we can barely fathom. They could help us unravel the deepest mysteries of the cosmos, from the nature of black holes to the very origins of the universe itself. This isn't just about faster computers. It's about gaining a new sense, a new way to understand and interact with the fabric of reality. The same power that threatens to break our world could also be the key to saving it. Perhaps, then, quantum computing is more than just a tool. It is a mirror, reflecting the boundless reach of human curiosity. We are a species that has always looked to the horizon and asked, what if? From charting the stars to splitting the atom, we have relentlessly pushed into the unknown. Now, we are venturing into the most mysterious territory of all, the subatomic realm of quantum mechanics. We are building machines that operate on the same fundamental principles that govern the universe itself. In doing so, we are not just creating a new form of technology. We are challenging our own understanding of consciousness, reality, and our place in the cosmos. The journey into the quantum age has just begun, and it promises to be the most transformative, most challenging, most profound leap that humanity has ever taken. What we will discover about the universe and about ourselves remains the greatest unanswered question. Thank you for joining us on this journey into the quantum realm. If you found this exploration as fascinating as we do, please consider liking this video and subscribing to our channel for more deep dives into the science and technology that will shape our future. We'd love to hear your thoughts in the comments below. Stay curious.